Hello everyone, welcome back to my channel Basics for Brain. Okay, so today we'll be seeing Ford-Fulkerson method, and I can guarantee you that if you see this video, you'll be able to solve every question of Ford-Fulkerson method. Okay, so coming to Ford-Fulkerson method, what it is used for? Ford-Fulkerson method is used for solving maximum flow problem. Okay, by maximum flow problem, what do I mean? Maximum flow problem means it's an optimization problem. Okay, it is a kind of optimization problem in graph theory that involves maximum amount of flow that can be sent maximum amount of flow that can be sent through a network of pipes and channels, subject to capacity constraint. Okay, this refers to maximum flow problem, and this kind of problem is solved by using Ford-Fulkerson method. Now the basic terms that are included in this method is: first, source; second, sink; third is capacity. That is capacity. In capacity we mean bottleneck and residual capacity. Okay, then augmenting path. Okay, now we'll see the meanings of these terms. Okay, so now we'll see the meanings of these terms. These basic terms are necessary to before going on questions. Okay, so first of all, source. Now, this source vertex has all outward edge. For example, if this is the source and everything should be like this, it should have all outward edge and no inward edge. Okay, and from source to sink, this would be, suppose, the destination is the sink. It would have everything. This is the destination, this is the source. It would have everything as inward. All are these inward only, inward edges. So sink would have all inward edges and no outward edge. Okay, now bottleneck capacity of the path is minimum capacity of any edge on the path. Okay, now residual capacity. Every edge of residual graph has a value called residual capacity, which is equal to, now this residual capacity is calculated as original capacity minus current flow. Okay, now augmenting path. Augmenting path is the path from source to sink through which we can push more flow. For example, if we write like this, now this 4 is the flow and the 5 is the capacity. Means the total is 5, out of which the current flow is 4. Okay, now we'll see a question and we'll see many examples, and after which you will get a clear idea of what the Ford-Fulkerson method does. Okay, see, if now this is the question given to you, how would you approach it or how would you solve it? First of all, we will write everything as this. These are the capacities given. Now the current flow 0. We'll write this. This is the first step that we would do. Write 0 here. This would be easy if we do further calculations. Okay, now the second step would be, we'll make this table. This is our path, augmenting path, and the bottleneck capacity. Okay, you can start like this only while solving the question. First, you'll make the diagram, write this, and then second, the table. First path we'll take is this: 1, 2, 5, and then 7. Now you see, in this path 1, 2, 5, and 7, in this path, what is the minimum capacity? It is 5. You'll write 5 here. Okay, write 5 here. So we'll write 5 here also. This 5 would be cancelled, this path would be filled. You'll cancel this path. Write 5 here also. So it is a 5 out of 7, and 5 out of 10. These are this only this path get cancelled because it gets filled 5 out of 5. Okay, now we'll see second path. 1, 3, 6 and 7. 1, 3, 6 and 7. Out of this, which is the minimum capacity? It is 4. Okay, so here it gets 4 out of 4. So again this path got cancelled. What is here? 4 out of 7 and 4 out of here 10. Okay, now we'll see another path. Now we'll take 1, 2, 4, 5 and 7. You can take any other path also, like 1, 3, 4, 5, 6, but it would be get long. We'll check this one first. Okay, now what is the minimum here? 1, 2. Now for seeing the minimum, see, for 1 on 1 and 2 path, it is 5 out of 7. The remaining is 7 minus 5 is 2. Okay, now for 2 and 4 path, it is 3. For 4 and 5 it is 2, and then for 4 and 5 it is 3, and then for 5 and 7 it is 5. So what is the minimum? It is 2 only. So we'll take 2 here, and then it would be 7 out of 7. Okay, so this would be again this path only got cancelled. It would be 2 here, 2 here, and 2 more here. So 5, 6, 7. So I'm writing it here. Okay, I'll write like clearly here. It would be 7 out of 10. Okay, so this path got cancelled. This path got cancelled. Now only one path left. 1, 2, 3. 1. So we'll take like this. Another path. 1, 3, 4, 5 and 7. Okay, only this path remaining. 1 to 3, and then to 4, then we'll go to 5, and then to 7, because the another path also got cancelled to reach 7, this one. Okay, now here what is the minimum? Again the minimum here is 1. Okay, how? From 1 and 1 to 3, you will see here it is 6 minimum. Okay, then to 3 and 4 it is 2. 4 to 5 it is 1. How? Because previously it got 2 here out of 3. So now the residual is 1 only. So the minimum is 1 here. So we'll take this one. Okay, so it would be here 5. Minimum is 1, no? So 5 here, 1 here, then it would be 3 by 3. It would be also get filled. This path got crossed. It would be 8 here. Okay, now we cannot take any other path here because every other path got cancelled. Here this path got cancelled. If we try to go by 1 to 3, then to 4, then to 6, but then we cannot reach 7. This path got cancelled. And we cannot reach 5 because this path is open, but we cannot reach 5 only because every no from every edge, this inward edge is crossed here. Okay, so this is the final. Now the final is 5 plus 4, 9, 10, 11 and 12. Okay, so this is the maximum flow. So our answer is 12. Okay, so we'll see another example here. So this is the question. I have already written this 0 over here. The first step I have already done. Okay, so we'll see the path one by one. Okay, first I am taking S, A, B and T. This one, first one, S, A, B and T. What is the minimum value over here? 4. Okay, so we'll write this 4 here, and we'll just cross this path because it becomes full, 4 out of 4. So we'll just cross this path. Here also 4, here also 4. Okay, now second we'll take S, then C, then D, and T. In this path, what is the minimum? It's 9. Okay, so we'll write 9 out of this 9, cross this path. Here it is 9, 9 out of 10. Okay, now we'll take, we can't go from A to B. We will take S, A, D, B, S, A, D, B, and T. I've taken this path. You can take another also. Okay, S, A, D, and T also can be taken. Okay, since I've taken this path, the minimum value over here is, here also 10 minus 4, 6, here 8, here 6, and here 6 only. So minimum value is 6 only. So if we'll write uh, this, the remaining value like 4 plus 6, it would be 10 only here. So it would be 10 on 10 here. So cross this path. Here 6. Okay, here 6. So cross this path again. Here again it would be 4 plus 6. So it would be 10 on 10. Okay, I'll write again. So this would be 10 by. So again this path would be crossed. We cannot reach sync to destination to sync here through any other path. This path is cut, this is cut, and if we can reach by here, but this path is only cut. So, and through D, if you can think that we can reach by A to D and then D to D, but from S to A only path is cut, so no more path. So the final answer is 9. 6 plus 4 plus 9 is 19. So our maximum flow is 19. Our answer is 19. Okay. If you ever got stuck, like from where there are multiple paths, or which path to take first, which to not, so just remember, take short edges first. Okay. Then rest. Do it rest. Okay. So I hope you like this lecture, and I hope you would be able to solve every question through this method. Thank you for watching. Please like, share, and subscribe.